In number 39, you got asterisk for a triangle trig. We want to evaluate the 6 trig functions of angle beta for cases A and B. So in the first triangle, we have a shorter side of 9, a longer side of 12, and an unknown hypotenuse, which we can find using Pythagorean theorem. So we have our hypotenuse squared is equal to 9 squared plus 12 squared, which is 81 plus 144, taking the square root on both sides. So we have c is equal to the square root of 81 plus 144, which gives us a value of 15. So now if we know that our hypotenuse is 15, we can solve for all of the trig functions of beta. So sine of beta is opposite over hypotenuse, which is 9 over 15. So we can divide by 3 in numerator and denominator to simplify. That'll be 3 over 5. Cosine beta is adjacent over hypotenuse, which is 12 over 15. So we can also simplify that to be 4 over 5. And tangent of beta is opposite over adjacent, which is 9 over 12. So we can also simplify that to be 3 over 4. Now for our triangle in B over here, we have a hypotenuse of 1, a longer leg of 0.7, and an unknown shorter side, a squared, or rather just a, that we can find using Pythagorean theorem. So we have that hypotenuse squared, 1 squared, is equal to 0.7 squared plus a squared. Rearranging for a gives a as the square root of 1 squared minus 0.7 squared. So a is equal to 0.714. So if we now know our value of a is 0.714, then we can find sine of beta. So sine of beta is going to be, looking at this angle here, our opposite side is 0.7, so that is 0.7 over 1. So multiplying by 10, we have 7 over 10. Cosine beta is going to be adjacent over hypotenuse, which is 0.714 over 1. So multiplying by 1,000, we have 714 over 1,000. And tangent of beta is going to be opposite over adjacent, which is 0.7 over 0.714, 0.7 over 0.714. So also multiplying by 1,000, we have 700 over 714 as our values for sine, cosine, and tangent.